this is a demonstration of the map coloring problem. So with this problem, here's my blog. What the problem is it consists of creating an agent that is capable of looking at a map of regions and coloring the map with specified colors so that no adjacent regions are the same color. And, here we have an example map that will be used in the testing procedure. So node 1 is connected to 2, 3, and 4. Node 2 is connected to 1, 4, and 3. Node 5 is connected to 1 and 4, and 4 is connected to all the others. So basically, here's the code. So what this code is downloaded from this site here. The first part of this code is to determine the adjacency of the regions in the map. So a region is adjacent if they're next to each other on the map, or if they're members next to each other on the map. So basically, what this line says is x and y are adjacent, then y and x are adjacent. So if x is adjacent to something, then to some y, then that y is also adjacent to the x. So now we have here the find regions. So what this allows us is to use the map, the adjacencies, in order to determine what the regions are, what the region R's are. So this will, if you call this, it will return a R that shows you all of the different regions on the map using adjacency in order to do that. And then so next we have the actual coloring. So this is to color. You insert a map, you insert the colors you want to use, and you insert a coloring, or the coloring will allow it to check for conflict, and then it will find regions, and so that will go back to here, and it will determine the regions that it needs to color. It will color all the regions with the colors. So here is the color all. It will use this to put a color, match up a color with a region, and then it will check for conflicts. And so here we have the conflict. So it takes a map and a coloring, and or a map with a coloring will return a conflict if R1 with color C and a specific coloring and R2 with color C, the same color C and a specific coloring, are adjacent. So if R1 and R2 are adjacent on the map with the same coloring and color, then there's a conflict. So now let's actually see this code in action. Oops, I forgot to open. I may have to open up a different, is it this one? Nope. Here we go, I found it. So here's the test that I'm going to be using. So once again, here we have SWI Prolog open, and we have the code that I just described. And so we're going to compile the buffer, and you see that 8 clauses. And so how we actually do this is, like I said, we put into the color, we want to color. Here, right here, I have a region that I'm going to color. So 1 and 2 are adjacent, 1 and 3 are adjacent, 1 and 4, 1 and 5, 2 and 3, 2 and 4, 3 and 4, 4 and 5. And that's actually, if you draw it out, that's the same map that I gave in the introduction. So I'm going to take this, I'm going to paste it in here, and hopefully it should successfully return this as the first possible combination. So 5 is red, 4 is green, 3 is blue, red. Let's just see if it works. And yep, it does. It returned this successfully. So now, in order to determine that it isn't just something random and that it actually can work, we'll take the same thing and just change it a little bit. So let's take it, Control C, put it into here. We can see now, let's say, so let's put, actually hold on, let me actually draw up a map really quick so that I can actually do this. Okay, so I've put into the prologue a statement now that should be a really simple map. It's just 1 to 2, 2 to 3, 3 to 4, and 3 to 5. So 1, 2, and 3 in a line, and then 4 and 5 branch off of 3 basically. So go away. So now if I run this, it should return us a solution that will work. And so it has returned 5 is red, 4 is red, that's fine because they both branch off of 3. 3 is green, that's fine. 1 is red, that's also fine, and 2 is blue. So you can see it is completely different from how it assigned this one, and it has assigned this in a successful way. So this code is capable of taking in a map and returning a way of coloring it with no conflicts.